This lesson we're going to be looking at solving logarithmic equations. We're going to do ones where there's only one log in the equation. We'll look at the next lesson what happens if there's more than one logarithmic expression in the equation. So let's look at number 1 here. We have 5 plus 4 times log base 5 of 3x plus 7 equals 13. And because there is only one variable in there, basically to isolate for that variable, we're going to do the order of operations backwards. So if you think about the order of operations, we have parentheses, exponents, multiplication and division, and addition and subtraction. So we have parentheses. We're going to go backwards with the order of operations to undo them. So we're going to save the parentheses for the end. So our first thing is we're going to look for is any addition and subtraction to get rid of. So we're going to subtract 5 from both sides of the equation. And what we do is we have left over 4 times log base 5 of 3x plus 7. And then on the right hand side we have 13 minus 5. So we're going to have 8 on the right hand side. Okay, so we did addition and subtraction. Next, let's cross that off. Next we have multiplication and division. So we have 4 times that log. So we're going to get rid of that multiplying by 4 by dividing both sides of the equal sign by 4. So 4 over 4 is 1. And then we have log base 5 of 3x plus 7 equals 2. So we're done with that. Now we got exponents. Now remember, logs find the exponent. So that would be our next thing we're going to do on the order of operations. There's a couple of ways of considering this. One way of considering this is just thinking about what logs find. Logs find the exponent. So this 2 over here, this could represent the exponent, and the 5 here represents the base of a power. So what we could do is just simply rewrite this as 5 squared equals 3x plus 7. So again, the 5 is the base of the log, and it's the base of the power. And this 2 right here, that represents the exponent of the power. And so we put that 5 squared. And then from there, we just simplify that equation. 5 squared is 25, is equals 3x plus 7. And then we just solve that as we would normally any linear algebra 1 problem. So we're going to subtract 7 from both sides, equals 3x, and divide both sides by 3, and we get 6. And there we go backwards, but also thinking about what's the opposite, the inverse of logs. The opposite or inverse of logs is using exponents. So whenever we have a log, we're going to rewrite it with exponents, with a power. So if we look at number 2, we have log of 10x plus 9 equals 2. And in this problem, we got to remember whenever there's no base that's written down, that is log base 10. So if we do the order of operations backwards, there's really nothing outside of the log to consider. So all we have to do is rewrite this log as a power. So the base of the log is 10, so the base of the power is 10, and logs equal the exponent. So 10 squared equals 10x plus 9. And then 10 squared is 100. And then from there, that should be fairly straightforward. We're going to subtract 9 from both sides. And we'll get 91 equals 10x, and divide both sides by 10. So then we get 91 over 10 equals x as our solution. Now, without doing a lot more examples, what if the expression equaled 0? So let me just rewrite this problem. What if we had log base 10 of 10x plus 9 equals 0? What would we do there? So we still have that base 10, so 10 to the 0 equals 10x plus 9. And then we just evaluate that 10 to the 0. And so anything to the 0 power is 1. Equals 10x, and then we can simplify that from there. Let's go on to problem number 3 and look at that one. So again, we're doing the order of operations backwards. We're going to save everything in the parentheses for the very end. So as we look for any addition and subtraction outside of the log. So we have that minus or negative 4 plus 6 times that log. So we're going to get rid of that by adding 4 to both sides, and we're left with 6 times the ln of 2x plus 5 equals, and we have 8 plus 4 is 12. So we got rid of addition and subtraction. Now we got to get rid of multiplication and division. So to get rid of that 6 there, we're going to divide both sides by 6 and simplify that. So 6 over 6 is 1. And then so we have the ln of 2x plus 5 equals, and then 12 divided by 6 is 2. So we got rid of that multiplication and division. So now we're going to look at exponents. So again, we're going to rewrite all logs using powers. So when we look at the natural log, ln, we just got to think about what's the base of the natural log. And the base of the natural log is log base e. So this ln is the same thing as log base e of 2x plus 5 equals 2. So we're going to rewrite that with that log base e right there. So with our new equation, we're going to change all logs into using exponents. So it's e squared equals 2x plus 5. Remember, logs, they equal the exponent. And then from there, we're just going to focus in on getting x all by itself. So to get x all by itself, we're going to subtract 5 from both sides of the equal sign. So then we're left with that 2x on the right. Now on this side, we're going to subtract this, but we can't combine them. So we still have the subtraction, but we just leave it like that. So e squared minus 5. And again, we're getting x all by itself. So our last thing we have to do is divide by 2. We divide the right hand by 2, and we divide the left side by 2. So on the right side, that 2 over 2, that does simplify to 1. On the left hand side, that does not simplify. So we're still going to divide by 2, but we just leave it there. So our final answer on that one is x equals e squared minus 5 divided by 2. It's kind of a bizarre looking answer, but that's the exact answer. If we want to get a decimal approximation, we would type that into the calculator, e squared, and then subtract 5 and divide that by 2. All right, and for our last example, we've got number 4 here. We got log of the base is x plus 12 of 5 equals 1/3. So again, to undo this log, we're going to rewrite it using powers. So we've got this base down here as an algebraic expression. That's going to be the base of our power. So x plus 12. And again, on the other side, that 1/3, that's going to be our exponent. So to the 1/3 power, and equals 5. So we change all logs into powers. Those are the opposites. And then we go through and trying to solve this problem. So we need to get rid of that 1/3. So to get rid of that 1/3, which remember that also means the cube root, we're going to cube both sides. And whenever we have a power, we multiply. So 3 times 1/3 is 1. So we're left with x plus 12 to the first power. We don't need to write that. And then on the right hand side, we have to simplify that. We have 5 to the third, which is 5 times 5 times 5, 125. And from there, that's fairly straightforward. We're going to subtract 12 from both sides, and there we find the value of x. So again, 2 things we got to keep in mind. We're using PEMDAS backwards with inverse operations. We already know the inverse operations of many different operators. So add and subtract are inverses, multiply and divide are inverses. So when we get down to logs, we're going to use exponents. It's called exponentiation. So we just rewrite all logs using exponents, and you should be good from there.